Welcome everybody to the online meetup. Today's topic is going to be real-world application orchestration made easy on VMware vCloud Air, vSphere, and VMware integrated OpenStack using TOSCA. And we have really great speakers today. So first of all, we have Nati Shalom, who is the founder and CTO at Gigaspaces, and he's a thought leader in cloud computing and big data technologies. Shalom was recently recognized as the top cloud computing blogger for CIOs by the CIO magazine, and his blog is listed as an excellent blog by Y Combinator. Shalom is the founder and also one of the leaders of OpenStack Israel Group, and is a frequent presenter at the industry conferences. The second speaker today is going to be Paco Gomez, who is a senior solution architect at VMware vCloud Air. Paco is a seasoned technologist, having extensive experience in diverse fields, including mainframes, distributed systems, enterprise development, cloud computing, mobile, assistive technology, electrical engineering, and embedded systems. Across his career, Paco has held positions in consulting, sales, engineering, product development, and entrepreneurship. As a third speaker who came on board kind of last minute is Yoram Weinreb from TOSCA/Gigaspaces. And Yoram, I would like to ask you to introduce yourself in just 1 minute. There's a few more logistics I need to provide. So first of all, if you guys have any questions during the session, feel free to ask those using the chat window on the left-hand side of the web panel. This session is going to be recorded, and the recording is going to be available approximately 48 hours after the session, along with the slides. So with that said, let me hand over to you, Yoram, as our third speaker, and why don't you go ahead and introduce yourself, and then let's hand over to Nati to kick off the presentation and then the demo.
Hi everyone, my name is Yoram Weinreb, and I'm an expert on OpenStack at Gigaspaces. I have over 20 years of experience in distributed computing, grid computing, and cloud computing most recently. I'll let Nati know.
Thanks very much, Yoram, and thanks, Raphael, for the introduction and kind words. First of all, I wanted to say that I'm very happy to be here. I'm actually very excited. Myself and Paco and Yoram here have been working as a team, I think, for over the past few months on making a lot of the things that you're going to see here something real. And going through that experience within a few months was pretty much a very exciting roller coaster in many ways. And to get to the point in which we can actually present something like this, for me, is a great achievement. And I wanted to thank you, Paco, personally for joining us today for this milestone. The way we wanted to lay it out in terms of the flow of the presentation is kind of start from the concept of hybrid cloud. I know that the people have been using hybrid cloud, and hybrid cloud has been used as a buzzword, wherein a lot of the actual use cases, what we actually saw is that it's very complex and it's almost undoable, and there is a lot of issues that comes to that to actually make it something real. So that, I think, was the reality. What I was found very interesting, especially as an OpenStack user, to find when I first introduced to vCloud Air, is that vCloud Air was actually born in a way for that use case. And unlike the Amazon and the Azure and Google of the world, they was really built to be an extension of the OpenStack environment or the private cloud environment. And in that context, I think they bring a lot of new ideas that are not, if you like, the regular public cloud that you're familiar with. So I would really encourage you to listen to that part of the discussion, and we'll touch base on that later on during the presentation itself, and we'll actually show the demos. So as I mentioned, the first part would be actually going through the introduction of both the vCloud Air and the new OpenStack, integrated OpenStack by VMware. Both of them are product by VMware. Paco Gomez, my colleague here, will be presenting that. The second part of the presentation will be going through how do we manage an application that runs on both my private cloud environment OpenStack in this specific case, and public cloud environment, be it vCloud Air, and use the same management, make the entire experience simple. And obviously, TOSCA being a cloud agnostic standard is vital for that experience, because if I have an orchestration that tied to a specific infrastructure, obviously I'm losing that level of portability. We'll end with 2 live demos. Actually, it's 3. First of all, it's demos that will show how the vCloud Air and the integrated OpenStack by VMware looks like, and we'll give you some pointers to that. And then we'll go through 2 examples. One example will demonstrate a simple use case, taking MongoDB and Node.js running on Docker. And the second example, more of a real-life use case of a Skype on demand, if you'd like. And with both of them, we wanted to show that all the concepts that we'll be discussing during the session are actually real. So I think we're introduced the speakers already. So kind of for the sake of time, I'll run through that faster. As an introduction, before Paco take over, I wanted to start with my view of the cloud stack, the way it is right now, and again, that's kind of the background for the discussion. What we're seeing evolving, and we're very familiar with the infrastructure as a service, platform as a service, and SaaS was kind of the common lingo for a long time. But the reality over the past few years is that the entire cloud stack have been more advanced, if you'd like, and it's also far richer than those 3 boxes that when we started the cloud journey was used. And if I really try to map the way organization, when I look to enterprises and when I look to telcos, what do they actually have in the data center, and how do they approach cloud, and where do they approach cloud? This is what I'm actually seeing. What I'm seeing is a fairly heterogeneous environment in which they have a private cloud environment based on VMware primarily, and OpenStack as kind of the new kid in the block there. We're seeing also every organization wants to have a leg in the public cloud, and they will choose Amazon, or they will choose Azure, or vCloud Air in this specific case, or Google App Engine. And as part of the trend toward Docker, which is a big movement right now, we're also seeing a rise of bare metal cloud coming together, and that's something very interesting. But the underlying message here is that even for a single enterprise or a single telco, it's not going to be just one thing that's going to run its infrastructure, both because of legacy, second because the transition to the new world is continuously changing. Similarly, we're seeing the thing on the application workload changing and evolving as well. So initially, 2 or 3 years ago, we started with configuration management like Chef and Puppet, or Bash script for that matter, to actually automate the configuration and management of our application in our data center. And over the past years, we've been introduced to platform as a service, which really provide a model to package our application and run it in a simple way. And very recently, Docker came to that world, and I think challenging a lot of those, both the configuration management and platform as a service. And it's still yet to be seen where that balance between all those 3 workloads, if you'd like, would fit together. As the mediator between those 2 environments, we're seeing a rise of new category, which is orchestration. So we can see Kubernetes coming from Google, which is very, very specific to Docker. We're seeing Heat as an orchestration that is tied to OpenStack, and we're seeing obviously Docker coming with its own orchestration that is obviously tied to Docker itself. And Cloudify, which is the thing that we'll be discussing today, is something that is more pure play orchestration that try to befriend, if you like, and work across those different cloud environment and hybrid cloud environment, and implements TOSCA as a result of that. So the bottom line of that slide is that when we approach a customer, when we approach an enterprise, probably going to see a mix of all that. There's not going to be one environment in which everything is OpenStack, or everything is VMware, or everything is elsewhere, and that raises a challenge in various aspects. How do we take our application, whether it's existing, legacy, or new application, and run it in this type of heterogeneous environment with all those tools, with all those options, and we all know that there's going to be new options down the road. So that's one challenge. The other challenge is we don't just want to move those applications into the cloud. We want to move to the cloud because we want agility. The reasons or the way to implement agility is through DevOps processes, which basically automate the entire cycle, the entire process from development to production. DevOps in itself raises a lot of complexity on how do we actually automate a lot of those processes that used to be manual before and used to run in different organizations. So how do we actually automate those processes to run well within the cloud environment? And not just that, we all seen a lot of articles written by Netflix and others about the best practices and how to run into the cloud. And we all seen that one thing that you need to anticipate or design to is that failure are going to happen. It's something that you need to design your application for failure. You cannot assume that the infrastructure will solve your failures. And therefore, you have to have automation processes in place to take those processes and make them simpler, like failover, and as well as other maintenance work like upgrades. So that's a challenge that we have today. I think that will be a good starting point to actually hand over to Paco to discuss what VMware brings to the table on the infrastructure level. Obviously, VMware is doing more than infrastructure, but we'll be focusing in this talk on two aspects, which is the VMware hybrid cloud strategy around vCloud Air, and the VMware integrated OpenStack, which is the new offering from VMware, which I found to be very, very interesting. And I'll let Paco kind of lead that part of the discussion. I'll later on follow up with the discussion on the blue box here, and that will be the second part of this talk. So with that, I'll hand over to Paco. Paco, the floor is yours.
Thank you, Nati. And thank you for your kind words as well. So when I work for vCloud Air. vCloud Air, for those of you that are not familiar, is the public cloud owned and operated by VMware. We call it the true hybrid cloud because the same technology that most of the data centers run on-premise, they have it now available on the cloud. We've been running this service for more than a year now, almost 2 years. And what this offers to customers is a true extension of their own data centers. It is common with our vCloud Air service that customers can move workloads from premise to the cloud seamlessly. In many cases, just moving VMs around, transferring the VMs from on-premise to the cloud, and keeping all the settings, no changes needed. The same vCenter server, vSphere technology that runs on-premise runs on the cloud. So those VMs can be transferred seamlessly to the cloud to provide elasticity and to extend the data center. So that's one of the benefits. The other benefit is that also in the networking, the cloud works as an extension of the own data center. The servers can continue having the same configuration settings. No changes in the networking are needed. Same with moving the VMs back from the cloud to on-premise if needed. And another benefit is that this can be managed with a single interface, the common interface that many IT managers IT administrators are used to manage. Are used to use to manage the on-premise infrastructure. They can do it with the public cloud infrastructure. Then with the security and support from VMware. So when we looked approximately a year ago, to have application blueprints, to have that type of service on vCloud Air, we looked at gigaspaces, and we like the cloudified solution that will be presented in a few minutes later. And we like it for several reasons. One is that first, it was supporting based on the Oasis standard, TOSCA, for application portability, and that support it was very important. It's a strategic decision to support that standard. The other positive thing we saw in the solution is that it was based on best practices. So the solution didn't have to reinvent the wheel to implement some of the functionality. I'll get back to that in a few moments. In this slide, what I have here is the fact that vCloud Air works as a public cloud on demand, so any user can really use it. It's really easy to sign up for the service just with a credit card and pay as you go. Just pay for the resources that you will be using. And the other fact that it provides what I mentioned before, workload portability. So the same VMs can be transferred back and forth from the on-premise to the cloud. So what we wanted to do with the application blueprints and to have to support TOSCA and portable applications is to take this portability a step forward and not just provide for portability and hybrid experience at the VM level, but really at the application level. And we found that TOSCA and the Cloudify implementation of TOSCA will allow us to have that truly portability between on-premise with vSphere, on-premise with the OpenStack implementation, and on the cloud with vCloud Air implementation. Next slide, please. Thank you. Just to give you a couple of other points on vCloud Air service, we provide, as a compute service, we provide a dedicated cloud where it's physically isolated between the tenants. That allows a higher level of isolation with performance, predictable performance. We have a virtual private cloud where basically the VMs can run on the same computes but are logically isolated. It's fully isolated, but with might be running multi-tenant in a compute server. And we also offer disaster recovery as a service. So customers that have their main data center on premise, they can use very easily set up a DR environment on vCloud Air. Next slide, please. Another differentiator of vCloud Air is that all the resources that are being consumed are very fine-grained. CPU, RAM, memory, storage, and customers get billed not by the predefined package sizes, but the aggregation of those, the usage of those resources. I want to go and review quickly because we don't have much time to cover all the items, but I want to cover about the new offering that VMware will be providing, making available within the next few weeks is the VMware integrated OpenStack. And this new offering is based on providing the OpenStack services and the APIs, compute, storage, image catalog, and networking, implemented with the industry reliability of software-defined data center infrastructure from VMware. So for next slide, please. For compute, the Nova services are implemented with VMware vSphere, given the industry reliability of the hypervisor and providing better utilization of compute resources compatible with OpenStack API. Same thing with networking. So the VMware integrated OpenStack will be offering the networking services implemented through NSX. Next slide, please. And same thing with the storage. Next slide, please. The Cinder service defined by OpenStack will be is implemented with vSphere or vSAN. So customers will have the option of having the storage provided by the data stores in the vSphere or data stores defined by vSAN. vSAN is another VMware product that offers virtualization storage where multiple servers can share their own storage and appear to the clients as a single storage system. And finally, the other service that will be implemented by the VMware integrated OpenStack will be the catalog glance, and has also very good benefits to in the next slide, please. With an advanced storage and availability of the images. So instead of transferring the image from the server to the machines where the VMs will be running, the images will be available immediately for VMs when the VMs run, as well as for snapshots. So that's a quick introduction for the VMware integrated OpenStack and vCloud Air. And with that, I will turn to Nati, please.
Thank you very much, Paco. So obviously, some of you can see the animation here. So I think we covered the infrastructure side of OpenStack, integrated OpenStack by VMware, and the vCloud Air portion. Obviously, we did it in a quick glance because we don't have a lot of time. Now I'm going to talk about the orchestration part. That's going to be based on Cloudify. And the role of that orchestration is really to enable us to deploy and manage application on both environments in a consistent way. At the end of the day, that's what we're trying to do here. As OpenStack users, you'll get the benefit of basically leveraging the vCloud Air cost benefit, as well as all the features that Paco mentioned. And we'll see how that works. So for those who are not familiar, TOSCA is an acronym. It's a specification that was developed by Oasis actually for a while now. Now we're in the second generation of that spec. And the idea is really to provide a standard way to describe applications workload across different cloud environments. By describing application, we're really talking about the ability to define the components of the application, the networking, the software, the infrastructure, the dependency between them, the monitoring, and all the aspects that we normally have in a lot of scripts and a lot of, if you like, definitions. And that's something that is very unique. So there are two things that are very unique to TOSCA. One of them is that it's infrastructure agnostic, unlike other specifications. For example, CloudFormation by Amazon is specific to Amazon. Hot by OpenStack is specific to OpenStack. The other thing that is unique to TOSCA is that it looks at the full life cycle of the application, not just the installation. So again, the two examples that I mentioned are really focusing on how do I interact with the API and deploy application, but less on how do I create a 360 degrees management and automation of the application lifecycle management. And those are the two aspects that I think TOSCA bring to the table here. The most important one for this discussion is really the portability aspect. And the fact that it's standard makes it very useful. So this is basically an example of a blueprint and what it comprises. That's the visual view of a blueprint. We'll soon see the YAML version of that, which is the actual script itself. So we could see here a typical application that is based on a web host, an application server, and a data tier, and a web host that is connected to that. What we can see just by looking at that slide is already a lot of if you like, information that we need to cover when we're describing such a blueprint. So for example, we could see that there are different kind of hosts. There is host for the web, and there is host for the application. By kind, I mean that they may be different in the size, in the operating system, in other characteristics, and therefore we want to give them a type and assign then the software components within those servers. So we can see that the web modules live within the web host and the application module live within the application host. Actually, in the application host, we also run the database in this specific case. We could also see that they're related and they have a relationship using arrows, and the relationship could be connected to, which means that I actually have a direct connection between one node and another node on a different host. And it could be contained in, which means that a certain software component needs to reside within a certain VM. And those are the type of things that we can express in a TOSCA definition, in a blueprint. Okay? So this is how the actual blueprint would look like. This is a simple case of WordPress. We can see that we have a node templates, which basically defines the elements that are mentioned in the previous diagram. And then for every element that is described here, there is a type, which basically maps to the actual implementation of that type. And then we have properties, which are the arguments or the configuration elements. And then we have requirements. Requirements is a way to assign, if you'd like, a software component to a host without specifying image ID or things that are specific to a cloud. That's the TOSCA way of doing it. We'll soon see that we can still use the regular image ID if we want to, but if we want to really keep everything portable, we'll use something like requirements. The other thing that we could see is that we could also define infrastructure in a portable way by defining a compute node based on its characteristics rather than based on its specific infrastructure ID or capabilities or size. And that would make our blueprint more portable. Another example that I use here is the ability to extend TOSCA. So for example, we needed to support Docker in this specific example. And what we have here in the example is a single VM that runs containers, 2 Docker containers for our web application based on Node.js, and a MongoDB database. Again, in our specific example, both of them runs within the same host, just to make things simpler. What we can see is that the TOSCA definition of that. The reasons why I'm showing it is to show that it's actually something that you could read, and most of you would actually be able to understand what it's actually doing. Where if I would use Bash script, or even if I use something like Chef or Puppet, the chances that you would have some level of abstraction at that level, that it will be that condensed and that short, is just something that shows you the usability of TOSCA, even for simple use cases, let alone more complex use cases in which all the details that would need to be exposed to make the entire scripts or manifest, as they're called, or cookbooks, almost unreadable, where in TOSCA we'll be able to parse them much simpler. So it provides a higher level of abstraction in which the value is for simple use cases, but mostly for more complex use cases. There is a more drilled down example that I provided here with a link for those who want to actually give it a try. So with that said, this is TOSCA. So TOSCA really defines the blueprint. What can we do with a blueprint? Obviously, we cannot do anything with a blueprint if there isn't an engine that can parse it and understand it and execute it. And that's where the orchestration engine comes into play. So Cloudify in our specific case is an orchestration engine, and a typical deployment cycle for that type of environment would mean that the first step that I would do is model the application within a blueprint, and that will include what are the components, how they connect to one another, and all those things that I mentioned earlier. And then we'll basically deploy or install this blueprint into the orchestration engine. The orchestration engine is basically acting like a robot that gets a task. It reads the task, which is the blueprint, and then it starts to execute it, and we'll soon see what that really means. After we've installed it, our job hasn't been finished, and actually some would say that it's only just started. And in that case, we need to do two things. One of them is manage our application in terms of logging, monitoring, all the things that are production readiness of our application, and also do continuous maintenance using workflow to do upgrades, to add more components, to increase the instances, and also automate things like healing in case of failure and auto-scaling in case we're running out of capacity. How do we do that? So the way it works, again, at the very high level, it looks something like this. So we have the TOSCA blueprint that we just defined when we modeled the application. Then we have the orchestration engine. In this case, it would be Cloudify, which at the end of the day creates application. In the case of vCloud Air, that resources would map to the actual vCloud Air resources. So note that by portability, we were not trying to hide the underlying infrastructure. We're not trying to create a least common denominator. The application and the blueprint itself is really exposed to the underlying infrastructure and actually expose them, because we believe that different clouds have different behaviors, and it's important that you would know in the terminology of the infrastructure that you're using exactly which resources are using, and not call it with some third level name that will be the least common denominator, and then it's very hard to understand what's going on. How does that map to portability? It maps to portability in two aspects. One, we condense all the differences between the infrastructure into one place, into one type, or a couple of types that I'm going to use in my application. Therefore, all my application is going to use the same type library, the same, if you like, plugin, and therefore have one centralized place in which that unique information resides. The second part is that as a user, I'm not exposed to that. The only one who is really exposed to that difference is the one who is packaging the application or defining that blueprint. The user that runs that blueprint doesn't need to know those details, and it will basically deploy the application. And if it runs on vCloud Air or if it runs on the OpenStack environment, will basically just map the application into the appropriate blueprint, and that will include the details of what it means to actually run it in there. And so from a user perspective, it could be fairly transparent. That's the other important thing. Similarly, for the VMware integrated OpenStack, we'll have the exact same thing, only that in this case, our blueprint would expose types that are specific to OpenStack and would map that to those list of resources. And again, from an end-user perspective, we'll just execute the blueprint, and behind the scenes, the execution of that blueprint would map, in this case, to the OpenStack resources rather than the vCloud Air resources. So that's a very simplistic view of how we actually going to do something like that. With that, I wanted to start with the live demos to show that it's actually real. We have two demos here. One of them is a simple demo using Docker and MongoDB and Node.js. And the other demo is showing a call center, a video chat, Skype on demand, as I would call it. But before we're actually going to use that, I'm going to hand over to my colleague Yoram, who's going to go over the two environments, the OpenStack environment and the VMware integrated OpenStack.
Thank you, Nati. So here, what we see is a view of the VIO, the OpenStack on the VMware OpenStack product, and what we can see here is that you have from the vSphere console, you can manage. There are plugins, and you can view and manage the actual OpenStack deployment, add the additional resources, clusters, and so on. And while this is loading up, I'll go to the vCloud Air. And on the vCloud Air, we can see that this is the console of the vCloud Air, public cloud offering of VMware. And you can see here the summary where you see the actual virtual data centers that you have, virtual machines, VApps, and the VMs inside them, and also the networking aspect, the rules that connect the machines to the outside world, as well as the networks that are defined for your virtual data center. And going back to the VIO, here we can see that you can see that there are the OpenStack plugin inside the vSphere, and you can also go into hosting clusters and see the actual all of the virtual machines that make of the infrastructure, as well as the virtual machines that you provision inside the OpenStack. Similarly, you can go to the actual OpenStack management console of this environment, and here you can launch your own VMs. Second. You can launch your own VMs. You can see a summary of the resources that you are currently utilizing inside the OpenStack view of the cloud, and you can look at networks and define networks in the network section of OpenStack.
Thank you very much, Yoram. I think that the important thing is that as an OpenStack user, you basically get a very compatible OpenStack environment. You use it just like any other OpenStack. So from that respect, it should be fairly straightforward. That gets me to the actual example itself. I'm going to start with a simple web application. We're going to install first a local environment using Vagrant. So I'm basically going to run the application on a local desktop environment, and that will include installing the Docker images. So we basically have a blueprint that maps to a local VM. The blueprint would, when I execute it, it will install the Docker images. It will configure the ports, the Docker ports that I can actually use it, and then it will run the application itself. We're then going to use the exact same application, but in this case, instead of pointing it to my local Vagrant environment, we're going to point it to vCloud Air. For sake of time, you could imagine how I do that. I do the exact same step, but instead of running it on vCloud Air, we'll do that in the OpenStack integrated OpenStack environment. But again, for the sake of time, we'll skip that step. I think you should trust me that that actually works. So let's see the actual video, how that looks like. We're going to start by the actually seeing the console itself. I'm not sure if you could see that. Do you see it well? Actually going to switch videos here. Okay. Okay, so what we can see here is that we're basically creating and installing Cloudify on my Vagrant VM. And that included a basic process of calling the command to actually clone the example from Git and then install it on my local desktop. So the only thing that I did is pip install Cloudify to install Cloudify on my local Vagrant VM, which is a basic Ubuntu VM called Precise64. Okay, and then after I installed it, and Cloudify now is installed on my environment, the next thing that I did is did check version just to make sure that it's there. I downloaded the example, the Docker example from GitHub, and then the next thing that I'm going to do is actually install it on my local desktop. Note that I use the command that is called cfi local, and cfi local really means that I'm going to run it without the management console. I'm not going to go through the details of that, but that's equivalent for those who are familiar with that to Chef Client or to a non-managed environment. It's basically a client-side way to run a script, to run the TOSCA blueprint. So one mode in which I can run the TOSCA blueprint is actually run it as a script and have a utility that parses the script and execute it on my local desktop. It could also run it remotely, but it basically just run the script without actually managing it. Okay, so the first thing was to actually tell the utility to actually point to that blueprint. The next thing that I did is called install. So the next command is called sudo cfi local execute -w, which stands for workflow, install. What install really does, it parses all the tree, the node elements within the blueprint itself, and it calls the lifecycle elements in that blueprint implicitly. So that's an implicit workflow. You don't need to actually write it. In this specific case, what it will do is it will create an image within my local environment. It will then install Docker. It will download the images for Docker. Then it will install the, actually those images comes with the software installed, so it only starts called the lifecycle of Docker to actually start the relevant service within the relevant image. So it will be MongoDB, as you could see here, on the first VM, and then it will be Node.js on the other VM. Okay, so now we basically, after we install the images for the first time, you could the actual time it will take me to actually start that application, and that's the nice thing about Docker, is less than 10 seconds. So running running MongoDB on my local desktop and Node.js, the second time would basically take that amount of time. Now we could use the command cfi local output to actually see the actual node, where that web application that I just deployed is running. In this case, I can actually see that I got my first application running on my local desktop. The second part would be to do the exact same thing on my vCloud Air environment. To do that, what I did is I actually going to install the vCloud Air plugin from the GitHub repository. This could actually be done implicitly, but in this case, we wanted to do that more explicitly so that you could actually see that I'm using vCloud Air plugin. And then, in this case, I'm not going to run the local version of the TOSCA parser, the cloudified TOSCA parser. I'm going to use a managed one. So the first thing that I'll do is bootstrap a manager on the vCloud environment. And what that manager gives me is a way to continuously manage the deployment after I install it and after I deployed it. And for that, I would use a command that is called cfi bootstrap, and I would give it the plugin, which in this case, it's the vCloud Air plugin that I just created a step before. And running very quickly with that, I can actually see now that the bootstrap process is taking place. The end result of that bootstrap would be a fully working environment. Okay. Now I can see that the management server has been installed and the manager bootstrap has been completed, and I can log in, see that the actual server is running. Similarly to the previous example, I'm downloading the actual example, the node seller example from GitHub. And in this case, I'm going to run a different blueprint. It's very similar blueprint, but in this case, it will be, for that same example, a blueprint that points to the vCloud Air environment. And the thing that I did is I basically uploaded that blueprint into the manager node that I created in the previous step. And the next step would be to actually create a deployment. And a deployment is basically an instance. So there is a blueprint, and I can create different instances of that blueprint. An instance for QA, for example, for production, for Department 1 or Department 2, depending on how I want to do. And now I'm logging into the Cloudify Manager to view the blueprint and view the deployment. And I can now use the GUI instead of the command line also to execute the install workflow. As I said, every blueprint comes with built-in implicit workflow for install and uninstall that basically go through the blueprint and execute every element in it based on the dependency tree. By the way it's done is that the parser load all the elements, then it finds out the relationship between them, and then it knows how to resolve that relationship and call the things in the right order. That in itself can be a fairly complex process. This is the view of the blueprint. I can see that I have some elements of input here, and I can see that now the application is being deployed. Very similar to the previous case, only that in this case I deploy it on the vCloud Air environment. So what I see in the simple use case is that I can use the same blueprint to run on a single node on my single machine without any management, just through a very simple installation. I just do pip install Cloudify and download the example and execute it, and I get a full environment running on my local desktop. And very similar way, I can actually run it on the vCloud Air environment. I can tell you again, for the sake of time, we'll skip that, that I use the exact same thing, but in this case point to the OpenStack blueprint, and that will do the exact same thing using the exact same step, but on OpenStack rather than on vCloud Air. Now let's see a more, if you'd like, a real use case example. In this case, I'm going to switch videos here to a different video. And the example here will basically work through the following steps here. So what we're going to actually deploy here is an environment which is called Clearwater. And that is basically an environment with 12 services, with user provisioning, edge proxy, and so forth. So again, for the sake of time, I'm going to run it more quicker. In this case, we're going to create the compute environment, set up the network services, which is the public DNS, as well as the security group, and all other networking elements. And then install the software. In this case, it will be using Chef. This is how the Clearwater application comes with. And obviously add to that the logging and monitoring and self-healing. There is a full details of that example in the reference section that I'll add towards the end of this presentation. Let's see how the video looks like. And basically, this will show how the example would work. That's the previous. All right. Just the example. Okay, so we can see the vCloud Air environment. We're now going to install the machines. Okay. Okay, so I just, for the sake of time, I'm running a little bit faster here. What we can see here is the actual blueprint. You could see interestingly enough, that the blueprint itself is very similar to the blueprint that the actual diagram that I used before. So one benefit that I get is that what I see is what I get. So the move from a PowerPoint presentation of my application into a management or real application management console looks pretty much the same. So I can visualize the application pretty much in the same way that I would visualize it in PowerPoint. And that in itself, for those who are experienced with that, is a big benefit. Now the next thing that I'm going to do is obviously install that application. similar to the one that I've done before. In this case, again, the configuration is not going to be based on Docker. It's going to be based on Chef. And that will set me up with all the instances. Again, for the sake of time, I'm going to run it a little bit faster here. What we should expect is that all the boxes here will turn green fairly quickly. That means that now they've been actually installed and executed. We're going through the actual blueprint. I'm going to again skip that. Let's see the actual deployment. And the interesting part, it would be not just to deploy the application and see how the execution of the deployment takes place, but actually see the service running. What does it mean? So now we can see that all the boxes turn green, which means that they've been installed successfully in this environment, and all the components are now running. Now, how do we know that it's running? We mentioned that the application itself is a video chat. So the right way to see that it's actually running is actually executing a video call and seeing that it actually provides that Skype services on demand as I was referring to before. So what we've done is we took another open source client, which is called Jitsi, and we can actually see that we're pointing the client, the SIP client, into that new server that we just created, and we're actually going to do a call with it. And that call is going to end up with a video call, and that will tell us that we're able to actually deploy the application and run it successfully in this environment. So we first started with a voice, and soon we'll hear.
Your camera. Okay. Hi, Aaron. Hi, Shai. How are you doing? I'm doing fine.
So I hope that you can see that video up and running. This is a video chat that was pointing to a new created environment that we've just created. In this case, on the vCloud Air, we've done the exact same thing on OpenStack. And that actually shows that we can actually take something relatively complex, like the one that I've shown you in this slide, and automate even something like that. And again, without changing the application code, just by wrapping it with a TOSCA-based blueprint, and that's the level of automation that we can expect. So with that, I'll hand over to Paco to do a quick summary, and then we'll open for questions.
Thanks, Nati. So evidently, the value that Cloudify brings to VMware customers is that with a single management interface, customers can deploy on a hybrid environment that include vSphere, OpenStack, and vCloud Air, as we saw during the demo. Specifically for vCloud Air customers is that we have a TOSCA compliant orchestration that will allow customers to deploy a microservices-based application, big data applications, NFV applications on the cloud in a simple way that is based on TOSCA, is portable, and allows to automate all the configuration of the application. And for OpenStack customers, it allows to deploy on-premise with OpenStack or in the cloud with the same application blueprint. Back to you, Nati.
Maybe you could touch on the availability here, Paco.
Yes. So this is currently available on the vCloud integration on the VMware Solution Exchange. The link is provided there. This will be available as a service later in Q2 in vCloud Air. So customers will just submit the blueprint and not worry to manage the orchestration engine by themselves. That's just a service.
Thank you very much.
And we provide a couple of links. Thank you.
Thank you very much, Paco. I think, Rafael, we're ready for Q&A if there is any. And as I said, we'll have all the... Yeah,
yes, there's plenty of questions that came in while you guys were presenting and demoing. So the first question is, how does autoscaling work on VIO, which is constrained by clusters? What happens when the scale exceeds the limits of vSphere cluster?
Well, obviously, we cannot change the law of physics, so we cannot spawn resources if they don't exist. But that's where vCloud Air, I think, comes as an extension. If you build your cloud offering with a pool of resources that can be extended from your data center into an external data center that looks just like your private data center, then obviously you could borrow resources as you go when you need to. And in that case, at least that's how I found the main benefit that I see in extending the data center using that is really that gives you that change in law of physics. By plugging in an extension to my data center to that type of, if you like, private-public resources that looks just like another machine, I can benefit from that extra capacity and also the cost benefit, which is the pay-as-you-go model. And that's how we would structure it. And in this case, that is the solution that has been presented here. Obviously, there are other ways to deal with that, but you'll have to have access to access resources to answer that question.
Okay, next question. What is the orchestration service used on that you're mentioning on slide 23?
Slide 23. Okay, so the orchestration engine is called Cloudify. Cloudify implements TOSCA, and it's an open source project. It's called getcloudify.org. Basically, this one on the right-hand side. And it's available on GitHub. It's free, open source.
So the next question, is TOSCA command line based, or can we also create a Docker instance using the UI, manage, monitor, and also using the UI?
Both. So both the command line and UI are supported. Obviously, DevOps guys are usually more handy with the command line, and Ops guys are, I found, more handy with the GUI, and therefore we support both.
Does Cloudify have plugins for AWS, Google Compute Engines, and the likes?
Yes, the answer is that for AWS there is a plugin already available. For GCE there is one being developed. It's actually a commitment that we have, so it's going to come down the road. We also have something that I didn't mention, vSphere plugin. So even if you have a VMware environment with vSphere API, that's also available as a plugin already in the environment itself.
Okay. Is it possible to seamlessly transfer and manage workloads from various public clouds to VMware vCloud Air and VMware integrated OpenStack private cloud?
Could you repeat that question again?
Is it possible to seamlessly transfer and manage workloads from various public clouds to VMware vCloud Air and VMware integrated OpenStack private cloud?
I'll let Paco answer the VMware side of that story. I would say that there are two ways to do that, right? One is at the infrastructure level, in which you migrate VMs and stuff like that, or at the orchestration level, in which you migrate workload. In our case, when we migrate workload, the workload themselves are basically software components that are not necessarily specific to the actual cloud environment if they are built correctly. And in that case, you could port them between different clouds. That's the promise of what we've been showing here today. So for example, in this example, we use Node.js and MongoDB, and we package that in a way in which I can run it on all of those environments, and it's not specific to any of the environment. There are ways to actually do migration, and I think Paco touched on at the infrastructure and VM level, and I'll let Paco touch on migration at that level. Paco?
Yeah,
did you get the idea?
Yes, there are several third-party solutions that provide migration from at the VM level. I think what is interesting here in TOSCA is that the standard, and not only the syntax, but also the architecture behind it. It really enables portability of applications based on the way this is architected. So the short answer to the question, yes, it is possible to have an application that has been defined in TOSCA and have it moved between cloud providers. That is possible.
Just to complete that, I know you mentioned that you're able to move VMs between the VMware environment into vCloud Air. I think the question was, can I do the same thing from an Amazon environment to vCloud Air or to
at the VM level?
Yes.
No, that's not possible because that format is not compatible.
Okay, that's what I assumed. Next question, Rafael.
Sure. So the next question is, can Cloudify act as an orchestration tool for both vCloud Air and AWS?
The answer is yes. Based on a similar architecture that I just mentioned, for us it's just a different plugin, and we have a plugin for OpenStack, we have a plugin for vCloud Air, as I think I've demonstrated, and also for Amazon. Actually, there is a new plugin coming from Amazon just right now that will use the Bodo interface and a little bit more advanced than the one that we have right now on the implementation that we have right now.
Okay. Are there any plans to create blueprints on a UI-based environment?
Oh, that's an excellent question. I was hoping to demonstrate it today, but I couldn't get my hands around that new tool. There is a new tool that is being developed. We call it the Blueprint Composer. And the Composer is basically a graphical editor for that YAML file that I just showed here. And it's kind of a WYSIWYG experience. You could drag and drop elements, and the output of that is a YAML file, and that gives you a way to edit the YAML file directly on the file itself, or using a graphical tool for that. So that's coming. I think it's scheduled for 3.2, which is end of April.
Okay, so there's still a couple of questions. So how do we connect Telnet SSH instance from public cloud to an instance in the private cloud?
Again, could you repeat the question? How do we connect what?
Yeah, sure. How do we connect via Telnet SSH instance from a public cloud to an instance in the private cloud?
First of all, there is if we're talking about SSH, there is a utility built in within Cloudify, which you do cphi SSH, and it will remember the key pair that you configured, and it will open an SSH channel to that. Other than that, part of the VM configuration on the blueprint itself could include the actual definition of that security key that you need to use to actually trigger that. Within vCloud Air, I think, Yoram, you mentioned that the ability to log in.
I think the question is more about public cloud and private cloud connectivity between them, and how do you make it transparent?
Oh, I see. I think that's more of a question to Paco, but as far as I understand, if I understand correctly, the way vCloud Air works at the networking level is that it does create an IPsec connection, VPN if you would like, between the public compute nodes and the public network and my private network. And from a networking perspective, it looks like they're all on the same network. Correct me if I'm wrong here, Paco.
No, I think that is correct. That is correct.
So the next question that we have from the audience is Cloudify competition to VMware VRO?
Actually, I don't know what is VMware VRO. That's the vRealize?
Yeah, vRealize.
The VMware orchestration product, yeah.
Oh, I see. Okay, that's for Paco.
Yeah, I don't see this as a competition. We've been talking about ways to integrate both tools, both having Cloudify to call VRO and vice versa, VRO calling Cloudify, because each product has its own use cases, specific use cases, and we've been actually discussing ways to integrate both. So I don't see this as a competition. Maybe you would like to elaborate a little bit more?
No, I think you've covered it pretty well.
Okay.
Okay, so the next question is, when will auto healing and auto scaling be available?
So auto healing is already available. Auto scaling, we actually don't going to demonstrate it tomorrow. So it's available, but not on the public. Both of them are scheduled for the 3.2 release. So the GA version of that would be end of April, but there's going to be milestones coming down the road that already show them. As I mentioned, auto healing is already part of those milestones, and auto scaling is I would say semi-available and will be available probably in a few weeks on milestones and in production by end of April.
Okay, so